Benign introduction. The substructure is the lower part of the structure, usually located below ground level. Ground level, although sometimes maybe the structure they will not show the ground level again, you need to know where the ground level is located. If here you have a hard core, this line where the hard core starts is exactly where your ground level starts again. And then it consists of foundation, footings and walls, and in some buildings include the basement. The measurement of substructure involves clearing the side. Clearing the side is removing each and every single thing on the side. Again, let's say if you find trees on a side and then you want to build, you can't build without clearing the side. Sometimes you even cut off those trees again so that the side can be cleared. Then you'll be able to start building. And then excavation, backfilling. Backfilling is the replacement of excavated earth inside the trench. And then keeping excavations free of water, calculating the risk of collapse. Risk of collapse, if you have a trench, this is your trench, this side there is a soil, this side there's also soil. So if this side there's soil and also this side there's soil, there's a risk that this soil can collapse inside this trench. There's a risk that this soil that is here can collapse inside this trench. So that is risk of collapse. And then concrete footing. This is the concrete footing, brickwork and faced brickwork. In cases where the substructure goes deep below ground level, it is measured provisionally as nobody can see what is below the surface and there could be obstructions such as rock or other material. Once the foundation has been built, it will also be remeasured and the necessary adjustment made to the measurements. And then 4.1.1, we have site clearance. They say site clearance is defined as the clearing, digging, and removal of all obstructions. Okay? And then excavation is any operation in which soil, rock, and other materials are on the ground are moved. And then there is backfilling. Backfill, which is the process of putting the soil back. Backfilling, if they want the width of backfill starts here until the on the sides of your wall, on the sides of the wall, that is where the backfilling happens. It is putting back the soil back into the trenches. And then there's a foundation wall. This is our foundation wall. The risk of collapse, I've already explained the risk of collapse. And then this is our concrete footing. Your wall cannot stand if there is no concrete footing again. And then the brickwork, which is in different sizes. Yeah, now we can start. We'll talk about the trades when we get to square bill and abstract. So now we are going to take off. Good question paper. It's 2012 again. 2012, 20 March. Question 1 says, the foundation plan and a section of an outbuilding are given. Specifications, clear site 2 meters beyond the external walls. So if you have a building here, and then inside you have your walls. Inside you have your wall. Let's say this is our wall, this is our wall. This building or the wall, if it ends here, it ends here, it ends here, it ends there. This is the outbuilding. It's called an outbuilding. So when you clear the site, you start here on the outbuilding, going that side. You start here on the outbuilding, going that side. You clear all the sides. You can't clear, let's say this is the length and also this is the length, 5,000, 5,000. You can't clear only this 5,000. You have to clear both sides. Also, the same applies to this one. So when they say clear side 2 meters beyond the external walls, as you can see here, we have the length which is 6,000 and then a width of 3,000. When you clear the side, you're going to take your length which is 6,000 and then you add 2 of 2,000. Whatever it is that they will have given you, 2 meters is 2,000. Again, if it was 1,5, it will be 1,500. So it's 6,000, you clear this side, you also clear that side. 3,000, you clear that the top part, you also clear this side. And then 15 MPa concrete, brickwork in structure bond and cement clay, stock bricks internally, face brick externally 2 courses below ground level. 1 course, it is the height of this brickwork. This is a course, it's 75. The height of a brickwork is called a course. It's 1 course again, it's 75. So if they say 2 courses, it means it's 75 times 2 again, which is 150. And then ground level, they say it is 185 above the top of concrete footing. There's something I want you to notice here. This is our natural ground level. This is our natural ground level. We have 200 here and we also have 75. We have 450 that starts on top of the concrete until where the surface bed ends. This is where the 450 ends. So if you want this space from here to there, what can you do? You can say 450 minus 200 minus 75. Please calculate. 450 minus 200 minus 75. What does it give us? 450 minus 200 minus 75. You know, like 175. So it means that this size is 175 again. But the specification says otherwise. The specification says the last bullet, it says ground level, it is 185 meters above the top of concrete footing. Remember I said this is the concrete footing again. This is the top of your concrete footing. So they are saying that the ground level from on top of the concrete footing, it is 185, but when we calculate, we got 175 again. So it means since they gave it to you, although the answers are different, since they gave it to you, you're going to use that one that they gave you, which is 185 when you calculate again, instead of the 175. If they had not said anything on the specification, this is how you will do it. 450 minus 200 minus 75, then you use that 175. But now they told you it is 185, it's not 175 again. So even though when you calculate you get 175, you are not going to use 175, you will use the one that they gave you on the specification. And then assume any specification not shown. 1.1, measure all the quantities for the foundation up to the underside of surface bed. So when a question comes like this, we need to do a checklist. Like if it doesn't come like this, if they don't say measure all the quantities, then there's no need for a checklist. Like 1.1, they'll tell you measure concrete footing. 1.2, measure brickwork again. But then here they just said measure all the quantities. So when a question comes like this, you have to do a checklist. So you are going to tell me what the checklist is. How do we start? What do we start with when we do the checklist? Checklist for foundation. What do we start with? Yeah? The name of the structure. What is the name of the structure? Substructure. And then checklist. And then we start with the site clearance. I'll write abbreviations. SC site clearance and then excavation. ROC. ROW. Concrete footing. Foundation wall or brickwork. Backfill. Cutaway. Hardcore. DPM. Facing. Do you all know this checklist by head? Mara, you were quiet. What? You say you know it, Mara, you were quiet. Only one person was giving me the checklist. Okay, fine. Is it correct? I'll shut this thing down. You start with the site clearance, then the excavation, then the risk of collapse, then ROW, risk of water, concrete footing, brickwork, backfill, cutaway, hardcore, DPM, facing the shop. Okay, so what are we going to start with? With the site clearance again. The reason for this checklist is that you need to go according to it. When you measure, you go according to this checklist. Like the checklist or measuring list is the list of the things that you should do on site. Okay, so the first thing that you need to do on site is site clearance. You cannot excavate where there are trees, where you have not cleared the site first. Again, so that's why we first clear our site. So let us clear the site, do dimension papers. You will open a bracket and then you write your description. Now, due to time, we're not going to write descriptions again, we're just going to abbreviate. So I'm just going to say CS, which is site clearance again. I guess the checklist says we start with the site clearance. So site clearance, we have a length. What is our length there? Okay, length, width, we have 6,000, and then I showed you what if we have 6,000 here, when you clear the side, you're going to clear the side and also the side again. Graph from here to there it's 2,000. Also from here to there it's 2,000. I guess they said we clear the side 2 meters. So it's 6,000. You cannot subtract. I get it from this 6,000. You are adding 2 meters. You are clearing 2 meters plus. Like we should, so plus 2 of 2,000. And then what does it give us? What? 10,000. And then we have 3,000 plus 2 of 2,000. What does it give us? 7,000. Okay. So when we take off, does our side clearance have height? Does side clearance have height? It doesn't. It doesn't. Like it is square meters. Okay. So square meter means that you take off 2 times. Like square meter is 2 things. Okay. So it is the length and then the width. So what's our length? 10,00. The width 7,00. Underline. What comes after side clearance? Excavation. So I'm going to excavate. Height of excavation. Excavation, we are dealing with soil again, and there is no soil that can be above the natural ground level. So it means that anything that has to do with soil, be it risk of collapse, excavation, or whatever it is, as long as it deals with soil, it needs to end here on the natural ground level. It cannot exceed again. So what is the height of our excavation? 450. This 450 exceeds the natural ground level. I just said anything that has to do with soil does not exceed natural ground level. This is where our natural ground level is. Okay. And this 450 exceeds. 185. We have 185 again. Where is this 185 coming from? The specification. They said that our natural ground level is 185 from on top of the footing. We don't use the one we calculate again. So it means that we have 185 here. And excavation, remember after site clearance, we have not yet put concrete, we have not yet put anything again. So it means that it is before the concrete, right? So it's going to be 185 plus 200. Our height is going to be 200 plus 185. What does it give us? 385. 385. And then the formula to write here is length, width, height. So it means our height is 385 and 0, 0, 39. 0,39. The width of the excavation is the width of the concrete footing, right? So here's our concrete footing. What's the width? 600. So it's 0,6. Width of the concrete footing is equal to width of excavation. Okay, and then the length of the excavation, okay, it is the center line, right? The length of the excavation is the center line. Length of excavation is the center line. Length is equal to center line. Center line formula says P minus 4 thickness of the wall. Okay, so we need to get the perimeter first. Formula for perimeter is 2L plus 2B. What is our length? 6,000. And then what is our width? 3,000. Okay, can I please ask, if I think right now our 6,000 has covered the walls, let's just say our diagram was like this. This is our 6,000. Would our length there still be 6,000? It is not covering the walls, so it would mean we would have to add the walls first again. Because when we excavate, we need the entire length that includes the walls. So what is our perimeter? 18,000. We did not want perimeter, wanted the center line again. So I'm going to say 18,000 minus 4 thickness of the wall. What is the thickness of our wall here? 330. Where are you getting the 330? Where are you getting the 330? From the concrete? Where? Between the what? Between the foundation. Foundation, this one, the what? Foundation hardcore. The hardcore, the length, height, sorry. We're looking for the height, we're talking about the. We're looking for length, we're talking about height. So length will be like. Length will be 30. Thickness of the wall is 30. Okay, length the excavation, you were. Okay, we're on excavation right now. It is length, width, and height. Again, we calculated the height. Height, it starts before the concrete footing until the truck ground level, right? And then the width is the width of concrete footing, which is 600. What is the length of the excavation? Center line. Okay. So right now we want to calculate the center line again. And center line is perimeter minus 4 thickness of the wall. So what is the thickness of the wall? Where are you getting the 330? Where do you see the one and Okay, you were saying, huh? What were you saying? We have 220 here. Why are you not saying the thickness of the wall is 220? Why are you saying it's 330? Because we are here. So what gives you a or like this little date? What's my question? Eh? Foundation wall is 38. Okay. The foundation wall is 38 again. Okay, what is the answer? What's our center line? 16,680. Oh, but what you were trying to say, you were really hard. And we made mistake there. We're putting length with height. So to put in medium. When? You will see it when you. Which one? You will see it when you write. I will see what? Come on. This one? You made mistake. You have to write something. And then, oh, you mean here? Yeah. It's the length, the width, and the height. What is our length? 16,68. And then our width? 0,60. The width of the footing again. And then our height? 0,29. 0,29? 0,39. Okay. Where is this 0,39 coming from? Height of concrete footing and okay, give us 385 again. Alright. After excavation, what is next? Okay, we're now going to the risk of collapse, ROC. ROC, as you said, it is square meter again, which is the length and height. It has no width again. So the length of risk of collapse is the center line, right? Length of risk of collapse is equal to the center line. What is our center line? 16,68. And then what is the height of risk of collapse? Height of risk of collapse is the same height as the excavation again. Once you get your height of excavation wrong, it means your height of risk of collapse will also be wrong. Risk of collapse, you're still dealing with soil again, so it's below natural ground level. You take the height of the concrete footing plus the height below ground level. It gave us 385 again, 0,39. And then risk of collapse. This is your trend. How many sides does the risk of collapse occur? There's the risk that the soil can collapse on this side, which is 1, and also on this side. So it's 2 again. You multiply the risk of collapse by 2. Okay? After risk of collapse, what comes? Risk of water. ROW. So risk of water, we keep the excavation free of water. When it rains, you cannot get the full quantity of the water that went inside the trench again. Even if you calculate, you can't get the full amount. So it's useless for you to calculate. It's item. You don't calculate anything. Risk of water, item. So here it's going to be item. And then what's the next thing? Remember to underline again. I might forget to underline here, but you should remember to underline it in your time and also open bracket. After risk of water, what comes? Concrete footing. Is this the concrete footing? This one? So concrete footing. Concrete footing, is it meter, square meter, or cubic meter? It's cubic meter. It has a length, a width, and a height. What is the height of our concrete footing? It's 200. Concrete footing is easy. You don't calculate anything. You just look at this footing. The height it will be given to is 200. The width it will be given to is 600. Like what? So the height is 0,20. The width is 0,60. What is the length of the concrete footing? Length of concrete footing is the center line again. So far on substructure, the things that use the center line thing, it's excavation, risk of collapse, and concrete footing again. So the concrete footing is 16,68. Okay. After concrete footing, what is after concrete footing? Foundation wall. It's square meter again. Foundation wall, which is square meter. Does the foundation wall also use center line? So it's 16,68. And then what is the height of our foundation wall? What is the height of our foundation wall? 185 plus 200. 185 plus 200. What does it give us? Eh? 385. 385. Is it all giving you 385? The foundation wall is this one again. It is this one. So the foundation wall is being reduced here under the surface bed level. So from here to here it's 185, and then from here to where it is reduced, it is 200 of the 1 core again. Yeah, so it's 185 plus the 200 for 1 core. You check where it started to be reduced again. So height is 185 plus 200 is 385. So it's 0, 0, 0,39. Okay, let us do our backfill. Backfill. So backfill is it meter, square meter, or cubic meter? Cubic meter. What is the length of the backfill? Length is equal to the center line, which is equal to 16,68. What is the width of the backfill? We don't have it, but we need to calculate it. Width of backfill is this space here after the wall. Backfill is on the sides of the wall again, so it's this space from here to there, and also from here to there. How can we get it? We can say the width of the wall, which is 600 again, minus the width of the foundation wall, which is 330. Then you divide by 2 because it's 2 sides. So what do you get? 135. Okay, so the height is equal to, the width is equal to 600 minus 330. What do you get here? 270. Then you divide by 2 again. It gives you 135. So it's 0,14. And then what is the height of our backfill? 185. Are you all saying it's 185? So it's 0,0.19. And then backfill, how many sides does backfill happen? 2 sides, okay? Length is the center line, the width is this spacing here. So you need to calculate that by taking the width of concrete footing, you subtract the width of the wall again, you then divide by 2. And then the height, backfill is below the natural ground level, and it starts here on top of the footing. So it's that 185. And then after, backfill, I was saying, how many sides does it happen? You backfill 2 sides, you backfill this side and also this side again. So it's two sides. So what else did you multiply by 2? The risk of collapse again. So risk of collapse you multiply by 2 because there's a risk that it can collapse from both sides, and also backfill. You backfill both sides. So you need to multiply here by 2. And then what is after backfill? Cut away. Cut away. Okay, what are we cutting away, or what is cut away? Yeah? We are cutting away the remaining soil. Okay, how do we calculate our cut away? Is it meter, square meter, or cubic meter? It's cubic meter. What is the length of cutaway? It's the center line again. The things that use center line on a substructure is what? The things that use the center line as the length. Does excavation use center line? And then what else? Risk of collapse. What else? Concrete. What else? The backfill. What else? Foundation. What else? Cutaway. Does the cutaway use center line? You guys center line 16,68. And then what is the width of cutaway? Okay, so cutaway, we're going to calculate it 2 times. I get cutaway for the concrete footing, which takes the dimensions of the concrete footing. The soil that is being cut away here is going to be replaced by the soil. I get, and then yeah, why does the cutaway brickwork take the size of the wall? Cutaway brickwork. Why does it take the size of the wall? Eh? This one, the reason the cutaway is not only here on the wall, again, cutaway, there was soil before there was concrete footing, right? And then they placed this concrete footing. When they placed the concrete footing, they placed concrete footing and here 600, here 200. So instead of the soil that was here, which was 600 and 200, probably like the concrete footing. And then there was also soil here. The soil that was here has been replaced by the 330 wall. That's why when you do cut away for the brickwork, you take the size of the wall. So cut away is that soil, the soil is being removed. And when it is being removed, it is replaced by what? By the concrete footing. It is replaced by what? By the brickwork. That's why that is why it takes the dimensions of the concrete footing and also the brickwork. You understand? Yeah. I get the side that will be backfill and also the side that will be backfill. Yeah. Okay. So let us first do the cutaway to the concrete again. I don't think it matters whether you start kaya concrete or kaya the brickwork. So cut away to the concrete is 16,68. It is the center line, the length, and then the width 600. I gotta remember, it is the soil that has been removed. What has that soil been replaced with? With the concrete footing. So it will take the dimension of the concrete footing again. The length is the center line, the width is the footing of the concrete footing. So it's 0,60. And then the height of the concrete footing, 0,20. You underline. We now go to, it's still in the same bracket again, it's not different bracket. When they say cut away, you cut away 2 times. Same bracket. It means that you underline here and then take off again. Still, the length is the center line, 16,68. What is the width? 330, 0,33. What is the height? 185. Yes, it is cut away. It is the soil that has been replaced with the wall. And the wall is not 185. The wall is 185 plus 200. But remember that cut away is soil again. So you can't exceed the initial ground level. That is why it's limited to 185 only again. Yeah. So it's 0,19. 185 is equal to 0,19. 0,19. Do you understand cut away? You do cut away to the concrete, you do cut away to the brickwork. Cut away is the soil that has been removed from the side, and that soil is being replaced by something. Again, even on this side, there is they remove the soil again. However, they replaced it with backfill. So cut away that was there has been replaced by the 330 wall. The soil that was here has been cutted away, and also this one has been replaced by the concrete footing. So it takes the dimension of the concrete footing and also the dimensions of the wall. And then after cut away, what comes after cut away? Hardcore. Yes. When I take accurate on this own Yaka foundation and Yaka. Yes, inside one bracket. Again, according to your checklist, there is cutaway. Again, on cutaway, you open one bracket, you do the cutaway to the brickwork, you underline, you do the cutaway to the concrete, you underline. You don't only do cutaway your brickwork. Yes, inside one bracket, you calculate the both of the. Okay, you were saying what comes after cutaway? In hard core. Okay, hard core is meter, square meter, cubic meter. Cubic meter. What is the length of our hard core? 6,000 minus 12 to 20. Why subtracting to 20? Why are you subtracting the 220? Hmm? It's 6,000, not 6,000 minus 220. Would you, why are you subtracting 220 on the hard core? And then why are you only saying it's 6,000? It includes the one. Here is our hard core. Is it including the one? So our hard core is cubic meter. When it's cubic meter, there's a length, a width, and a height. When you are dealing with the hard core, look at the diagram. The diagram is talking to you. It says, listen to me. So this diagram, it shows you that this hard core is not including the wall. Which wall? The 221? No, the 331. It's right here next to the 331. So what you're going to do is you're going to say, I have my length, which is 6,000. On this 6,000, I need to subtract the wall, 330 two times. You're subtracting it this side, you're also subtracting it this side.